Assalamu alaikum. We know capacitor is a charge storing device. In this video, we'll discuss a circuit that contains a capacitor connected to an AC source. For that, I consider one capacitor. We know capacitor is represented by this symbol. When two lines drawn parallel to each other, it represents a capacitor. So one such a capacitor of capacitance C is taken and connected to an AC source. This is the symbol of AC. AC. This is an AC source to which the capacitor is connected in a parallel. Now, at any instant, the voltage in this circuit is given as the instantaneous AC voltage is given as V, which is equal to Vm sin omega t. I take this as equation number 1. Now here we have capacitor of capacitance C. As I told you, it is used to store charges. In case of a capacitor, remember this. As we provide charge to the capacitor, with increase in charge, the voltage in the capacitor increases. So we can say Q is directly proportional to V. So this clearly shows that as Q value increases, V value will also increase. Now, when I remove this proportionality, I have to include a constant. A constant is included here. This constant is represented letter C. It is called as proportionality constant, and here C stands for capacitance of the capacitor. It tells us the capacity of a capacitor to hold that how much charge do a capacitor holds. It's given by this letter C, this capacitance. Capacitance of the capacitor right here. So from this, if we cross multiply, the value of C obtained to be equal to ratio of charge and voltage Q upon V. Suppose our capacitor is connected in open circuit. In such case, this voltage is replaced with EMF. Okay. So the place of V, I will have epsilon. Epsilon stands for EMF. So now I am going to use this equation here. This I am going to use here. So this want to be equal to Q upon epsilon. Here Q is the charge and the epsilon is the EMF in the capacitor. Okay. Then the value of a Q from here is going to be, now I will find out the value of epsilon is the Q upon K. I'll keep this as such. Now I'll go ahead. I'll box this value. So I take it as equation number 2. Now I'm going to apply Kirchhoff's voltage rule to this circuit. Applying Kirchhoff's loop rule, which is otherwise known as Kirchhoff's voltage rule. Now applying Kirchhoff's loop rule to this circuit. And what does it say? It says that the total voltage in a loop is 0. Okay, the sum of total voltages in a circuit is 0, which is otherwise represented as sum of voltages in a circuit. Sum of a voltage in a circuit is equal to sum of a EMF. This is another way of representing Kirchhoff's second rule or Kirchhoff's voltage rule. Okay. So if you look at this, now I'm going to substitute the value of voltage. In our circuit, the voltage, the total voltage is given by letter V, which is represented by equation number 1, and EMF is represented by equation number 2. Okay, here I have equated this two. Now I'm going to substitute the value of V and epsilon. What's the value of V? V is nothing but this Vm sin omega t, and epsilon is Q upon C. Now what is my aim here? Now I know the value of instantaneous voltage. Now I'm going to find out the expression for instantaneous current. This is for what I am doing all these things. So for that, I keep Q this side and C is taken to the left hand side. Now it's dividing here. When it's taken to the left hand side, it will multiply. CVM sin of omega t. This is what I have taken. I take it as equation number 3. Now we know that current I is nothing but rate of flow of charges. Now how many charges flow through a conductor in a given time? Rate of flow of charges is nothing but current. Here we know the value of Q from equation number 3. This is equation number 3. Now here to find the value of I substitute 3 in this equation. I take this equation number 4. Now to get the expression for instantaneous current, I am going to substitute equation number 3 and 4. Substitute in 3 in 4. This will provide me the expression for instantaneous current. The above equation can be written as I equals to d upon dt of I. Here we know the value of it's not I, it's the Q. We know the value of Q from equation number 3, that I am going to substitute here. What I will get equal to, so d upon dt CVM sin omega t. This is what I will get. Now the next step, I will differentiate that term d by dt of CVM sin omega t. Now here we know we cannot differentiate a constant, so that the constant term CVM is constant here is taken out, and I will differentiate only this term sin omega t. Now with respect to time, I am going to differentiate this. If I do so, what I will get? See, what do I get? I will become equal to CVM, and differentiating this one, I get omega sin omega t becomes omega cos omega t. This is what I obtain. Okay, and here omega is angular velocity. Now I bring it outside. I becomes equal to omega c Vm cos of omega t. Now I am going to make a small changes to this. See, what do I do? You need to observe this. You need to look at this very carefully. I becomes equal to Vm. Now is written as such. Then I take omega c to the denominator to keep the value unchanged. So what I do, I write it like this: 1 upon omega c. Now when this term is taken to numerator, I obtain this value. So both the things provide me the same value. Both the equation provide me the same thing. Okay, this is what I obtain here. Now this term 1 upon omega c, I write it here. Here the term 1 upon omega c is nothing but xc, which is called as the capacitive reactance. What is this? Here xc is called as capacitive reactance. Here we have used the term, a new term called as reactance. We know what is resistance. Resistance is nothing but opposition to the flow of a current. In a similar way, if the current is opposed by some other component other than a resistor, then we use the term reactance. Here we have a capacitor in the circuit connected to a source of alternating current. So definitely it is going to provide some resistance. It will offer some resistance to the flow of current. So this resistance offered by the capacitor to the flow of current is referred as reactance. Here it is known as capacitor reactance, represented by letter Xc. So in the place of 1 upon omega c, I am going to write that. So I becomes equal to Vm upon Xc cos of omega t. Here Xc performs the work of resistance as it is done by a resistor in an AC circuit with a pure resistor. Okay, whatever resistor does in a AC circuit with pure resistor, the same work is done by Xc in this circuit. Now we know V upon R according to Ohm's law is nothing but current. In the similar way, here similarly Vm upon Xc is taken as Im. Here Im is the peak current. As we know, Vm is the peak voltage, so Im is the maximum or a peak current. So this term is replaced with the Im. So what I'll get in the next equation, I becomes equal to capital Im cos of omega t. If you want in the place of capital Im, you can also write small im. It is not going to make any difference. Okay. Now I'll make small changes to this. Here cos of omega t can be written as sin of omega t plus 90 degree. Okay. Here we know the value of pi in degrees is 180 degree. It is so pi by 2 is equal to 90 degree. So in the place of 90 degree, I can write a pi by 2. So I'll make a small change to this. I'll write this in the next step. I is equal to Im sin of omega t. In the place of 90, I'll write pi by 2. This is the final expression which represents the instantaneous current in this AC circuit. Okay, which contains only a capacitor. This is taken as equation number 5. So equation 1 and equation 5 represents the instantaneous voltage and the instantaneous current in the given circuit. Clear? Now this I box for better visibility. Now if you observe equation number 1 and 5, you will find that In 5, in comparison to equation number 1, the angle is increased by 90 degree. So this clearly shows that current leads voltage by 90 degree. So I leads V by 90 degree. Okay, this is what we understand. Now I'm going to show this to you with the help of a waveform diagram. Okay, I will draw a graph by taking voltage and current along the x-axis. Voltage and current, voltage along the x-axis, and time angle, that is omega t, is taken along the y-axis. This omega t. What is so? Okay. The sinusoidal wave represents the voltage. This represents voltage. Clear? What is so? I will also take a current along y-axis. Now to represent this, once you look at carefully what I do. When voltage is at a 0, by that time current would have reached 90 degree. Okay, this is what it means. Notice so when the voltage is here, then the current will be somewhere here at a 90 degree. Clear? Starting point. First I mark the positions. See, this is the this goes this way. Okay. This is the relation. This graph represents I. Okay. This waveform diagram represents the relation between voltage and current. Okay, which clearly shows that current leads the voltage by 90 degree. Now, how to understand this? See, voltage starts with 0. When voltage is at 0, current is at a 90 degree. Okay, starting point is 90 degree. So, then the starting point may lie somewhere here. Is what it means. Okay. Now, just I continue this one. Now I'm going to draw a phasor diagram. This one is wave diagram. I will represent the phasor diagram. Okay, what does the phasor diagram say? Draw the phasor diagram. Just draw a line here. Then its projection. Its projection will give me the phasor. No, and it's going to provide me a phasor diagram. Okay, clear? This is the projection. Okay, how do I represent this? The projection from this point gives me the phasor. Not the phasor that represents the voltage. What is so? Then, with respect to this position, let's extend this one. It will provide me, see this line that I draw here. It provides me the phasor diagram of current. Okay, this point is I. Now, if you look at the angle between them, is nothing but 90 degree. The angle between these two is 90 degree. So this clearly shows that I leads the voltage by 90 degrees. This is what it represents. This is how one can get the expression for instantaneous voltage and current in an AC circuit containing a pure capacitor. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.